Hey guys, how's it going? In this tutorial, we're going to be building a UI or front end for a lottery smart contract using the Web3js library. Now we've developed the lottery Solidity smart contract that we'll be using in previous videos, so if you haven't seen those videos first, I highly recommend you check those out. Or you could just download the completed smart contract code from GitHub and proceed with building the UI here. That would be totally fine as well. The links to both are in the description below. At the end of this tutorial, we'll have a fully functioning lottery dApp or decentralized application running on the Ethereum Rinkeby test network. So if that sounds good, stick around and let's get right into it. Alright guys, so before we get started on coding, let's just go over a quick high-level roadmap for this tutorial. First, we'll be creating a basic static UI using NextJS, React.js, and the Bulma Css library for a bit of styling help. Then, we'll create a Connect Wallet button and add functionality to connect to the site using our Metamask wallets. After that, we'll deploy the lottery smart contract to the Ethereum test network using Truffle. Finally, we'll come back to our lottery front-end application and build out the functionality needed to interact with the smart contract on Ethereum using the Web3js library. Alright, so let's set up the basic structure for our front-end application. Now, the one prerequisite here is that you'll have to make sure that you have Node.js installed on your system. I recommend version 16 as that's the latest stable version at the time of this video. You could probably get away with 17 or even 14, but I'd suggest shooting for 16. So you can just download that for your particular system, and you may have to restart your machine before we start actually coding. Alright, so the next step, we want to move into the folder or directory where you want to create your project, and let's go ahead and open up a terminal window. And the first thing I'm going to do is to create a new folder for our entire project. So I'm going to say make directory lottery. Alright, now I'm going to cd into that lottery directory. And the next step is going to be to create the scaffolding for our NextJS application. So we can say npx create next app at latest to ensure we're getting the latest install files. Go ahead and press enter, and it will prompt us for a name for our application. So I'm going to say lottery-dApp. There we go. And so that's going to go ahead and install all of the dependencies, all of the sort of scaffolding for our project. And this may take a minute, so I'll go ahead and pause the video for now. All right, so once that installation step is complete, let's go ahead and cd into our new directory, lottery-dApp. All right, and we've got one more dependency that we want to install, and that is for the Bulma Css library. So let's do npm I for install, Bulma. And again, that'll just take a second to install. There we go. Okay, let's go ahead and open up our code editor and see what we've got so far. So I've been using Visual Studio Code for quite a while now. I definitely recommend that to you guys, but you could use, of course, you could use the editor of your choice. All right, and I'm going to go ahead and open up I'm going to do open folder. And I'm going to open up the lottery directory, the top level directory for our project. All right, and you can go ahead and X out this little get started page here. Now I'm going to expand the lottery dApp, and as you can see, we've got the scaffolding for an entire NextJS application. We've got our package.js with a couple of default scripts there. And then the way this is organized is that, so NextJS comes with routing out of the box, and it's really pretty convenient. You've got this pages directory here, and if you expand that, basically every JS file corresponds to a route here. So index.js, let's go ahead and pop that open. This is just our default route, so this is going to correspond to localhost 3000 dash, or just the, basically no route, the default route. So this is going to be our home page. And we'll just use this to develop our lottery application. We're going to get rid of all this code here and start from scratch. But just to kind of see how this is going to work, well, the first thing, let's go ahead and add the import for our Bulma library so we don't have to do that later. So I'm going to say import Bulma -css Bulma.css. And so that's going to grab the primary Bulma CSS file from our node modules folder where Bulma is installed. All right, so just to kind of see this working, let's go down to our, well, I'll tell you what, let's just start the application. So go back to your terminal. And by the way, you can use the Visual Code terminal right here. I'm just kind of used to using a separate terminal for some reason. So to start our application, we can do npm run dev. Now we can also do npm run start, but in order to do that, we'd have to actually build the application, run a build step. So npm run dev lets us sort of run our project directly from our source code. So during development, that's really convenient. Go ahead and hit enter. And we should see the project open up in a new browser on localhost port 3000. And if you don't see that browser window pop open, you could just sort of open up a new window and navigate to localhost 3000. There we go, and there is our default application. All right, so let's see how we can make a quick edit to this and see that reflected on the page. So if we go back to our code editor, let's scroll down a little bit and let's look at this welcome message on line 17. So let's just replace this whole thing, including the anchor tag, and let's just write lottery dApp. All right, go ahead and save that and go back to your browser. Refresh, and we should see that reflected. Great. And you're also seeing a sort of shift in the CSS styles, and that's due to our Bulma library kicking in. All right, perfect. So let's go ahead and start coding our lottery dApp. All right, so we can now start building out the front end for our application. So let's start by just doing a little cleanup here. Let's get rid of this image on line 2. And on line 7, let's get rid of this class name. We're not going to be using this. You see there's a default container style, but that sort of conflicts with the Bulma container, so we're going to delete this. Let's update the title of the application. So we were calling this lottery dApp. You can call it anything you want. I'm going to actually change the name to Ether Lottery. Okay. And let's update the description here. So I just want to say Ethereum Lottery dApp. Simple enough for now. Okay. Maybe we'll update this favicon later, so we'll leave the link for now. Now let's get rid of everything under this main tag right here. So starting from line 15, I'm going to go all the way down to about line 52 and just delete everything. We're going to start fresh there. Oops. Now for the footer, I'm going to get rid of everything inside the footer, but I'm going to leave the actual footer because we do want to have a footer for our website. Let's just go ahead and do a quick copyright sort of text here. So I'll do a paragraph tag, and then I'll use the copy HTML entity. That'll give us the copyright symbol. Say 2002. Now you can write whatever you want here. I'm just going to do block explorer. There we go. All right, so we're starting with an empty, basically everything, the content of our site, it's going to go within these two main tags here. So we'll start empty there for now. Let's save that. Let's go and let's open up in the styles directory, let's open up the home.modules.css. So I want to delete everything in here except for the footer styles. So let's go all the way from the bottom up to where we start to see some footer kind of styles, right about up to line 31. And I'll keep main as well. All right, but I'm basically going to delete everything inside of it for now. All right, let's go ahead and save that. All right, so let's take a quick look at the lottery smart contract and just think about what kind of content we want to show in the main content area of our website. So we've got things like a list of players that have entered the lottery. We've got a lottery history, which is a list of previous games and who won them. Then we've got things like the total lottery pot, or all the money that the winner is going to get. And then we've got functions such as enter, to enter the lottery, right down here, and then pick winner. So I think these are some of the things that we'd want to show in our UI. So the two functions, the enter and the pick winner, I think these are going to be buttons that we might want to show in the main sort of viewport. And then I could imagine where off to the side in sort of the column, we might want to show some information like the list of players, the lottery history, and the total pot. So given that, let's sort of create some structure for that. I think we're going to want to have like a column-based structure. So we'll have maybe 2 columns for the main interface where the buttons are, and then maybe a 1/3 of a column or 1/3 of a grid to show the sidebar and some information there. All right, and also the top of the page, we want to show some sort of logo or, lottery, dApp, Ether lottery, some sort of bigger text, and then off to the right-hand side, we might want to show the connect wallet button. So to do that, we can use the Bulma navbar structure. So let's create a nav wrapper. Okay. And so at the top level, we can do a class name navbar, and this is a Bulma convention. This will just give us some nice padding and spacing for our nav element. And then inside that, we can do a container. So we'll do div class name equals container. And this is a Bulma container, again, just something to give us some structure and some nice padding, default padding out of the box. All right, so again, to lean on Bulma, we can use something called navbar brand, which will give us an area on the left-hand side of our navbar for a logo or header text or something like that. So we'll say div class name navbar brand. There we go. Let's close that up. And so inside of navbar brand, let's just do a h1 tag for now. And I'll say Ether lottery. Okay. Now at the same level as navbar brand, we can use another Bulma class called navbar end. Again, this is going to be on a div. We'll say class name navbar end. And what this does is it positions an element to the right-hand side of the navbar. So inside of here, we can do a button element for our connect wallet button. And we'll give it some Bulma classes to help style it a bit. So we'll say button is link. And so for the text, we can say connect wallet. Now you might be wondering about this button is link. And again, these just come from the Bulma library. So I'll just kind of show you in the docs what that looks like. So this is just a good reference. I kind of like to have this open while I'm developing any Bulma-based application. And I think button is, it's under form elements. Where is that? There we go, button. So there's a lot of customizability that you can do with Bulma, but it gives you a lot of cool default classes. And this is what I'm using right here, this sort of purple variant of the button. And you can see the reference code button is link. And so there's all different kind of styles. You have the light version of the buttons that we'll use later, I think, on some of them. And you've got different button sizes. So I just kind of like to have this open as a reference. All right, let's go back to our code editor. All right, so underneath, sort of at the same level as our navigation element, we can go right under that and let's create a main wrapper for the rest of the content for the page. So I'll say div class name, and let's just give this a container. And again, container is just sort of a generic class that gives us some spacing, some structure for our application. All right, so within the main container element, we can just start creating different sections. So we're going to have 2 buttons for starters. We're going to have a enter button to enter the lottery, and then we'll have another one underneath that one for a choose winner or pick winner. So we'll say section, and section is just a HTML element. And let's give it some padding we know right off the bat that we'll need some padding, otherwise it'll just sort of bump right into the nav bar. So I think once I create one of these, I can sort of do some copying. MT5 is a atomic element that, or an atomic class name that Bulma provides, margin top 5. And there's 1 through 6, I believe. So you can do MT for margin top, you could do MB for margin bottom, and then sort of choose the level, 1 being the least, 6 being the most. So we'll go for 5 for now. And again, all this, you can find all this information in the Bulma documentation that I was just showing. All right, so within this section, we want to create some further structure by using columns. So columns are similar to what you may have seen in other CSS frameworks as grid. And I'll show you what I mean in just a second. So we'll do div class name equals column. And now we can specify the width of the column by using this sort of English, very English-like class name is 2/3. And for the other one, you could probably guess we're going to do is 1/3. And so that'll give us 1 full row. So we'll go ahead and just copy this div right here and paste it right underneath, and I'll say is 1/3. So what I'm thinking is in the 2/3 area, we'll have some buttons for entering the lottery and for choosing the winner. And in the 1/3, that's sort of like the side panel off to the right that will show information about the lottery pot, the list of players, and the lottery history. So let's just put up some placeholder text for now. Lottery info, and then here, let's just do lottery buttons. All right, let's save that and just kind of see what we have for now, where we're at, and go back over to our... Okay, good. So we still got a long way to go here, but we've got the basic structure set up, buttons, and this info should really be over to the right. So we'll figure out how to do that in just a second. Anyway, we've got a basic structure coming into place. All right, so I think to fix our column issue, we can actually need to get rid of this S at the end of is 1/3, not 1/3. So that should fix that problem. And then we're seeing the footer sort of like all the way up to the top of the page. So go ahead and save that. Let's make some style changes here. So in our main wrapper, we can fix that issue by specifying a minimum height. So min-height, and we'll say 100 VH. Okay, and that should give us a minimum. That should sort of push that footer all the way down to the bottom of the page. Now we can set some styles for our h1 tag inside of the main element. So we'll say .main h1, and let's first let's boost the font size. Font dash size. Let's say 3M and see how that looks. Let's give it a bit of a bolder. Font weight equals bold. Yeah, let's go ahead and make it bold. And then, whoops. And so you may have noticed that it was black before we added Bulma, and then it sort of turned to this gray color. I think I like the original black, so this is totally optional, of course. You can style it however you want, but I liked that black that we initially had, so I'm going to change that. Let's save that and see how things are looking. Yeah, that's much better. So and our footer is at the bottom now, so I'm still not sure why this structure isn't quite working. Let's go back to the code and see. Main, we've got nav, and then we've got a container. Under that, we've got MT5. Oh, you know what? We're missing a columns element. So we've got to let Bulma know that we're trying to make columns here. So I think I just forgot one level here. We go under section. Let's create another div with a class name of columns. That way it'll understand this is 2/3. You got to give it some context for that. So I'm going to move this over a bit, and let's close that div. I think that was the missing piece. Let's save that and check again. Yeah, exactly. All right, cool. So that's the basic structure that I'm looking for. All right, so let's start to kind of flesh out these areas, the buttons and the lottery info. All right, so for the buttons, we'll get rid of this p tag here. Now we're going to have two of them, so we'll separate each sort of button area with another section. So I'll say section, section. And we want to give each one a little bit of top padding so they don't like butt up against each other. So say class name equals MT5 for margin top 5. Okay, now go ahead and close that up. All right, so let's first add some text here. So we'll do the enter lottery button first. So I'll just put a little preamble here. I'll say enter the lottery by sending 0.01 Ether. If you remember, our smart contract had a check to make sure that the person was sending in at least 0.01 Ether. Okay. And underneath that, we'll have our button element. So say button class name equals button. And we'll say play now. Or you can say enter or whatever you want. Okay. Let's take a look at how that looks so far. All right, perfect. We've got a little button over here. Now we'll add some more padding and we'll give this guy a color. We also need some padding above our connect wallet button. So let's address those issues next. Go back to our code editor. And let's see, let's go up to our nav bar and let's just put some padding on top of the entire nav bar. So I'll say margin top 4, margin bottom 4. Save that. And let's go back to the button that we just created. And let's give it some additional styling. So again, we can use the Bulma button styling. We can say is-link. And let's make sure this is a large button. And let's use the light styles, is light. And let's give it a margin top of 3. Let's see how that looks. Great, that's much better. Okay, so we're also going to want a choose winner button. And remember, that's only available to the admin or the owner of the smart contract. So, you know, in a real world application, we might want to have this somehow hidden. But we'll just rely on the smart contract logic to reject the transaction if someone other than the owner calls this button. And for the sake of simplicity, we'll just add that button right here. All right, so we can just go ahead and copy this entire section. Let's see, starting at right here on line 29. Just copy the entire thing. And we'll just change the text first of all. Let's say admin only, pick winner. And let's just throw a bold tag around this admin only. Pick winner. And we'll say pick winner for the button text. And let's make this one a slightly different color. So instead of is link, let's make it is success. Or actually, let's make it a is primary. That's a bit of a lighter green tone. So let's save that, see how that looks. All right, not bad. I'd like a little more spacing between these two, so let's go back here and for section, let's do margin top 6. So we'll max it out there. And yeah, let's see how that works. All right, great. Yeah, that gives us a little more separation here. Cool, I think that's looking good so far. Let's go ahead and let's start to create some structure for the lottery info. So if we remembered, we had 3 sections that we wanted to do. We have a lottery history, lottery players, and then lottery pot. So what we can do, Bulma has a component called cards. I think that'll work really well for this. Yeah, so card. And there's various options, but it's, you know, little sort of UI widgets or card elements. And I think we'll just use kind of a plain one, more like this. without any header or footer. You can have headers or footers, but this is just kind of the basic structure for this. A class card, card content, and content. So we'll just do something basic like this. All right, so let's go down to our 1/3 column, and we can get rid of our sort of placeholder text here. So let's do a section. Class name, let's do a margin top 5. So similar to what we did before on the other side. And so inside here, we can create a div with a class name card. And that is that Bulma class that's going to allow us to style this as a card. And then we'll do a card content. And we'll only have to write this out once because we're just going to copy for the other two. That was card content, I believe. Yeah, card content. Oops, content. Close that up. All right, and finally, we've got one more div with simply the class name content. And again, we'll close that up. There's a little bit of typing at this stage just to get things going, but should be a lot less after we've got this basic structure set up. All right, so let's do a H2 tag inside of here. And for the first one, let's do lottery history. Lottery history. All right, and then let's create another div for the content of this. And this is just going to be a custom class name. So we'll say history entry, just so we have a little bit of control over this content here. And so what's this going to look like? We may have like a paragraph tag inside of here. Or you know what, we may just have like another div. So let's do div. Let's just put some placeholder text for now. We'll make this dynamic later, because all this information is going to come from the smart contract. Lottery winner, and this is going to display an Ethereum address. So let's grab an address just from my Metamask wallet. All right, and I'm just going to copy the address here and come back over here and let's paste that in. All right, and let's put this inside a div as well. All right, let's just save that and see how that looks so far. Yeah, that looks pretty good. Okay, so we need to widen things a bit just to make sure it can contain that very long address here. Another thing that might be kind of cool is if we link this to Etherscan. You know, you can go to Etherscan and look up any address or token. So here's my wallet address, and we can look that up. So it'd be kind of cool if we could have that link to this page. So let's grab the URL, and let's go back and let's create an anchor tag around this. Okay, so I'm going to say href equals, and I'm going to paste in that address. And again, we'll make this dynamic a little bit later. But for now, let's just hard code this in. And then another thing we probably want is to make sure this opens in a new window. So I'll say target equals underscore blank. There we go. Let's check this again. Yeah, so now this is a link, and this should take us directly to our Etherscan page. Great. Okay, so far so good. All right, so let's go ahead and build out our 2 remaining cards, and We'll save some keystrokes here by copying what we have for the first card. So let's see, I'm going to copy this whole section right here. And let's just go underneath our existing section close tag on line 56. And let's just copy that 2 more times. 1 and 2. All right, there. So now we just need to modify the second 2 to what we want. So for the second one, let's say players. So we'll change lottery history to players, and this is just going to be a list of players that are currently entered into the lottery. So we'll have a little count right here, and again, we'll make this dynamic later. And then let's just grab this whole section right here with the div that's containing our anchor tag, and we'll just we can remove this history entry. We don't need that anymore, and let's just paste that directly below our players count. All right, cool. So for the last one, let's make this the pot. So instead of lottery history, we'll just say pot. So this one's going to be real simple. We'll just get rid of the entire history entry, which goes down to about line 82. And let's just hard code a value for now. So let's use a paragraph tag, and let's say 10 ether. Go ahead and save that. Great, so we've got 3 cards off to the right-hand side. Looking good. So we still need to fix this where the account number is sort of running off the edge of the card. You know, I really don't want to do any major restructuring, so let's just fix the font size for these. And so how can we do that? We've got card class names, and so we can sort of target card and then anchor underneath that. So let's do that. Let's make an entry for card and then A. And then let's do a font size. Let's try 0.9 EM. Let's see how that looks. If that's still too big, we can take it down some more. I'm not seeing any change. Did we target that right? So we've got card and then anchor underneath card. All right, so I think what we need to do here is actually make a new module class, CSS module. So let's create a new class here, and we'll say, instead of card, since that's a Bulma class, let's just do lottery info and then target A underneath that. So let's go back over here and we'll put the lottery info class at the top level. So we've got to do something similar to like what we have here, styles names. Let's just copy this whole thing, and we need to do styles.lotteryinfo to target our new modules class. So let's see. We want that right about, let's see, right about here, but we've already got some classes, so what we're going to have to do is, let's see, we're going to have to use some string literal syntax. So if I recall, this would go something like this. Here we go, styles main in there, and $, styles main, and then the rest of the classes. I believe that's correct. Let's try that. Not yet. Oh, I forgot to change the main. Okay. Lottery info. There we go. Try that again. Info is not defined. Yeah, I think it just doesn't like that dash in the class name. Let's just do lottery info like one word. Go back to our CSS, lottery info. Let's try that. There we go. That's exactly what I wanted. Cool, so now our Ethereum addresses are fitting inside our cards, and things are looking good. All right, so at this point, I think we've got a good enough structure to sort of turn our attention to the Connect Wallet button, and let's start to wire up the functionality so that this Connect button will actually open up our Metamask and ask us to authenticate to the site. All right, so the first thing we need to do is head on back to the terminal, and we need to install the Web3 library. So I'm just going to clear this out, and I'm going to type in npm I web3. Now remember, Web3 is a JavaScript-based library that allows us to interact with smart contracts on the blockchain, And it also has some functions for allowing us to interact with our wallet, with Metamask in this case. And we're going to use it to get the list of accounts and to prompt Metamask to open up and ask for authentication to the site. So I'll just pause the video while this is installing. All right, great. So our installation is complete. So let's go back over to the code editor. Let's go back to our index.js file all the way up to the top. And the first thing we need to do is actually import the Web3 library. So I'll say import Web3, capital Web3, from lowercase web3, which references the installed module. Okay, so what we want to accomplish here is we want to have something happen when we click on the Connect Wallet button, right? We want to prompt Metamask to open up. So we need a click handler on the Connect Wallet button, which means we need a function that click handler will call. So let's define a new function. We'll go right up here under our default function name. And let's say const, let's say connect wallet handler. Okay, now this is going to need to be an async function, so I'll use the async keyword. And we'll use fat arrow syntax here. Great, so we've got an empty function for now, and we'll fill that out in just a second. For now, let's grab the function name, and let's go down and find our button. And let's just add an onClick handler. So onClick with a capital C as per the React convention. Now inside a pair of curly brackets, we'll just enter our connect wallet handler name. All right. So the first thing we need to do is have a check to make sure that Metamask is installed and to make sure that generally that we're in a browser environment. And the reason for that is because Metamask actually injects a wallet provider under the window object, which is a global object in JavaScript. And so we just need to make sure that that's available for us to use. So I'm going to say if, and here's the code to check for that. So I'm going to say type of window is not equal to undefined. Okay, and that's just basically a check to make sure that we're in a browser environment. And we want to make sure that the Metamask Ethereum object has been injected under the window object. So we can do another similar check here. Type of window.ethereum is not equal to undefined. All right. So let's add some curly braces, and we'll have an else statement. Oops. And here we'll just sort of log an error. If I can spell else right. There we go. So we'll say console.log, please install Metamask. All right, and so I want to comment everything we're doing here just so it's really clear. So I'll just add some comments and I'll say check if Metamask is installed. And really we're also checking to make sure that we're in a browser environment, but I'll just leave that off for now. And then Metamask is not installed. Okay, cool. So now underneath our if statement, so the happy path, the green path, if everything's going well, and I need to close this comment, we're going to attempt to connect to Metamask. So we'll put this all in a try catch clause, just so we catch an error in case something goes awry. So in our catch, we'll look for an error message and we'll just console log that out. Okay, so if something goes wrong with opening up Metamask or authenticating, we'll catch that error here and log it to the console. All right, so the first thing we're going to do is request wallet connection. So we'll just leave a comment there. And for this, we're going to use await, because it's an async function, window.ethereum. .request, and this is going to take an object with a method with the value eth_request accounts. And this syntax is just very specific to Metamask's API. So we're calling a request on the Ethereum wallet provider that they've injected into Window. So this is what's going to actually cause the Metamask application to open. All right, so the next thing we need to do is create a Web3 instance, and we'll pass in that Ethereum wallet provider into that constructor for the Web3 instance. Okay, so I'll say create Web3 instance. Okay, and so what we actually need to do here is once we create that instance, so let's just write out that code first. Take it one step at a time. So I'm going to say Web3 lowercase equals new Web3 because it's a constructor function, and we're going to pass in we got to pass in a wallet provider. So let's say window.ethereum using that wallet provider that Metamask has installed for us. Now what we want to do, we're going to use this Web3, not only for getting the list of accounts, which is our next step, but we're going to also use it later on to invoke methods on our smart contract. So what we need to do is set this into a state variable. So we can use the React useState hook. Let's go ahead and add that to the top of our page. So I'm going to do import useState from React. Okay, so now we can go ahead and create a state variable for Web3. So I'm going to do const, and in array syntax, we're going to say Web3, and the second argument is going to be a setter function. So we'll say set Web3 equals useState. Okay, and we'll just pass in, we won't pass in any argument here. So it'll be set as undefined. And so now what we can do here, we can set this to state. Okay, so we'll use our setter function and we'll send in the Web3 instance that we've just created. All right, perfect. So the next thing we want to do is get the list of accounts. And similarly, what we're going to do is we're going to leverage React, the React useState hook to set the account at 0 into our state, into our application state. Okay, so let's say get list of accounts. Okay, so we'll set up a variable for accounts that we're going to get back, and we'll say await Web3. We're using our Web3 instance now, and we can call eth.getAccounts. Perfect. So let's, for now, we'll set account 1 to our state variable. Set account 1 to React state. So we can say, oh, we got to set up that variable first, actually. So we'll say const address, and we'll say set address. And we'll say use state. So now we can say set address, and we'll say accounts at 0 position. Okay, because this is going to give us an array of accounts, so we're just looking for the first one for now. All right, we'll just comment this one as well. Just so it's super clear. React state. All right, perfect. So with this, let's go ahead and save the file, and let's go back to the browser and let's see if this is working at all. All right, so let's click on Connect Wallet. I'm going to open up the console just in case we have any errors or anything like that. Connect Wallet, and there we go. Great, so I'll go ahead and approve the connection for account 1. And we are now connected. I could verify that by opening up again, and we see this little connected icon right here. So great, our Connect Wallet functionality is working, and I think we're at a good stopping point for now to sort of turn our attention to deploying our smart contract, our lottery smart contract, to Ethereum Rinkeby testnet. So we've got to have a working contract out there before we can really go much farther and start to use Web3 to interact with that contract. All right, guys, so let's go ahead and deploy our lottery smart contract to Ethereum. Now, I'm going to go through the steps in this section a little bit quickly just because I've covered this before in a couple of previous videos now. But if you guys want a more slower paced sort of line-by-line guide to this process, I definitely recommend you check out the Smart Contract Testing and Deployment Guide. And I'll add a link to that video in the description of this one. So we will cover every step, it's just we won't go into great detail or depth on each step. We'll just sort of go through the motions here. So the first thing I'm going to do is go into my top-level project directory, and let's open up a new terminal. And I'm going to create a new folder, so we'll say make dir, and I'm going to call this lottery. Okay, and this is going to be the folder for our smart contract deployment. All right, once that's done, let's go ahead and cd into lottery. Oops, lottery, not lootery. Lottery, there we go. Okay, so step one, or step two, I guess, is to initialize an Npm project. So I'm going to do npm init. Okay, and I'm just going to accept all the defaults. Great. All right, so the next thing I'm going to do is install Truffle. And this is something where I want to install it globally. So if you guys haven't used Truffle before, then you want to do npm I with a G flag for global and Truffle. And if you already have this installed, then you can just skip this step. Okay, and this will take a second, so I'm just going to pause the video. All right, perfect. So next thing we want to do is initialize a Truffle project. So all I have to do is type in Truffle init. And this is going to set up the scaffolding for a new Truffle project for us. And that was pretty quick. So we need a couple of things. We need to install a few more things while we're here. So let's just take care of that. We need .env, so we're going to use .env files to hold some of our project variables. And then we need something else called HD wallet provider. So that's also a Truffle package. So we'll do @truffle / HD wallet - provider. And I think those are all the dependencies we need for now. If there's something I'm forgetting, we'll come back later. All right, so while this is installing, let's go back over to our code editor and let's kind of, we can close these UI files for now, and let's see what the Truffle init scaffolding has given us. So I'm gonna go ahead and close up lottery dApp for now, and let's open lottery. And perfect, so we can see we've got a Truffle config file. This will be pretty important for us. And then we'll need to copy our contract, our lottery contract, into the contracts folder. You can see there's a migrations contract that Truffle has given us by default. You can pretty much ignore this. This is basically just a separate contract to track our deployments so that, you know, if we try to run our migration and we haven't had any changes, it will sort of detect that. Or if we've only changed one contract, it will sort of know the status of our deployed contracts and only deploy that one that has the changes. So anyway, not really much to worry about there. Let's tell you what, let's go ahead and create a new file. And we'll say lottery.sol, and this is going to be our lottery smart contract. And I keep on misspelling lottery. There we go. Okay, and so like I mentioned before, we've already kind of gone through the process of creating the lottery contract in another video, which I'm linking in the description. So for now, for the purpose of this video, we're just going to sort of grab the code from GitHub. And this should be, again, I will link this in the description so you guys can have access to this contract. But it's this one right here, the lottery with Chainlink VRN. Okay, and just go into raw mode here, and we can literally copy and paste this whole thing. All right. Go ahead and save that. Perfect. Okay, so one more thing we need to do is under the migrations folder, we need to create another migration script for our lottery contract. So what I like to do is just copy the first one here that's given to us by default, and then we'll just, there are only a very few things we have to modify. So first let's change the name. And we'll say to lottery migration. Go ahead and save that. And then we just need to sort of modify some of the keywords here. So yeah, this should be lottery. Basically, wherever you see migrations, you can do a find in place and replace it with lottery. There you go. And go ahead and save that. All right, perfect. So the next thing, we're moving along pretty quickly here. Let's go ahead and create a .env file. So I'm going to do .env. Okay, perfect. And let's go ahead and open up our Truffle Config file. All right, so at the very top, there are a few things that we're going to want to add. All right, so at the very top, there are a few things we're going to want to add, and the first one is a require statement for our .env, for the .env module. And so the way this works is you require it, and then you do .config. All right, next line. We'll set up a variable for our HD wallet provider. And we'll say require at truffle / HD wallet provider. All right. Now we're going to be reading the private key from our .env file to keep it safe, and we'll make sure it doesn't get, checked into GitHub or anything like that. So we'll actually write the reference to that right now, even though we don't have it yet. So I'll say private _ keys. And the reason why I say keys is because this is basically an array. Okay. And so inside here, we can just have an array of one item. So I'll say process.env private _ key _1. And I believe that's all we need, one private key. So let's save that. Now back to our env file, what we want to do is basically set up an environment variable that matches this right here. So I'm going to go ahead and copy private key 1. I'm going to go back here, and let's save that for now. Now, what I want to do is export the private key from my Metamask wallet. So, by the way, I should have mentioned this before, but one of the requirements for this project is to have Metamask installed. So if you don't, it's really easy. Just Google it, go to metamask.io, click on the download link right here. It's just a browser extension. So all you have to do is choose your operating system, install MetaMask for Chrome, and sort of follow the prompts from there. All right. So since I already have it installed, and I'll close a couple of these for now. I'll close this for now. What I want to do is open MetaMask. And I want to make sure that I'm on account number 1. This is the one I'm going to use for deployment. Rinkeby test network. Okay. And if you click on this colorful icon, or sorry, it's not the colorful icon, it's the 3-dot menu and account details. That's what I want. There's an option called export private key. So click on that. And definitely this warning is pretty important, never to close this key. This is the key to your wallet. So anyone who has access to the private key can basically has access to all the funds in your wallet. So not something you want to share. Keep it in a safe place. Okay, and I'm copying it right here, and I'm going to go back to the code editor and go ahead and copy that into my .env file. Okay. So it doesn't look like we have a Git Ignore, but I'm going to create one real quick just because it's good practice, because you never ever want to, check in your .env file that contains your private key anywhere. So we'll say .env, save that. Okay. Back to Truffle Config. So if we scroll down a bit, not that fast, scroll down a bit, there's a networks property on line 44, and everything's sort of commented out, but here's where you can sort of tell Truffle which test environment you're targeting for deployment. So what I'm going to do is I'm going to create a new entry. I'm actually going to select Ropestein, and I'm just going to uncomment that. Okay, and we're going to repurpose this for Rinkeby. So there we go. So I'm just going to rename this Rinkeby Test Network. Okay, and let's go ahead and get this filled out. Okay, so let's see, new HD wallet provider. We can delete everything inside of the curly braces. Okay, so we're going to do this by private key, not by mnemonic, which was the default as you saw there. So I'm going to say private keys. And again, we can reference the variable that we created up at the top, which was called private keys. So I'm going to copy that. I'm going to paste it down here. Okay, place a comma right after that. And what doesn't it like here? Comma expected. Oh, this is an object. Yeah, inside HD wallet provider, that should be an object, since we're passing in a config object here with multiple properties. Okay, so provider or URL. Just do an empty string for now. We'll come back and fill that in a second. Number of addresses, we'll just do 1. All right, so network ID, let's change it from 3 to 4 for Rinkeby. And you can, I'm not going to bother with changing all these comments. We'll just leave that for now. And everything else we can just leave as is. Okay, so for the wallet provider, we're going to use something called Infura, which I've described in more detail in previous videos, but basically it is a service that allows us to interact with nodes on the Ethereum blockchain. So if you don't have an account, you can go to infura.io, I believe that's what it is, yeah. And you can sign up here, go through the process. It'll collect an email and ask you to create a password and things like that. But it's a pretty simple sign up process. So once you've signed up for an account, and it'll let you, use a certain amount of requests for free. So the free tier should be more than enough for this video. And what I'm going to do is I'm going to create a new project. Product. Select Ethereum. A name, I'm going to say lottery. Lottery dApp maybe. Okay, and I'm going to do create over project allotment. Okay, so it will only let me create 3 projects, so I'm going to delete this one since I'm not using it anymore. There we go. So let's try this again. Ethereum, and let's just call it lottery. Cool. Okay. So in the project settings or the project details, it's going to give us some information that we want. So there's a drop down called endpoints, and we want to make sure we change this to Rinkeby. Now, all we have to do is copy the URL for this first HTTPS endpoint. There we go. Copy it to your clipboard, and let's go back into our code editor. And let's go ahead and just paste that right here where it says provider or URL. And what we can do is we can actually make this an environment variable. So the very last part of the URL is your API key. So go ahead and cut that. Let's go back to env, and let's create one more new variable. Infura API key equals, and then just paste that. And go ahead and grab this key here, save the file, back to config. And so we'll use a string literal here, so we can use this variable. Oops, backtick, and this will be $, curly braces, and end curly braces. There we go. Okay, so far so good. All right, so now our configuration is done, and we can go ahead and attempt to deploy this thing to the Rinkeby test network. So let's go ahead and open up our terminal. And I'm going to go ahead and close this out for now. Make sure it's the right terminal, the one that is in the lottery directory. There we go. Okay. So what I'm going to do is type in our deploy command, which is Truffle Migrate. And migrate is synonymous for deploy, basically in Truffle speak. So we'll set a network flag, and we'll say Rinkeby. And let's go ahead and try this out. Go ahead and hit enter. And if something's incorrectly configured, then we'll get an error message and deal with it, but let's see how it goes. Command failed. Ah, okay. I've seen this one before. So, consumer base I see. Okay. So we were using Chainlink to get a verifiable random number in our lottery contract. And so we need to actually install Chainlink contracts. All right, so let's do npm I at Chainlink /contracts. And that'll go ahead and install those dependencies for us. And again, if you guys want to hear more about how Chainlink works and how it helps us get a verifiable random number, definitely check out the first two lottery smart contract videos. All right, that's installed. One other thing that I just thought of, we need to make sure that our compiler version is correct. Yeah, it looks like it is in my case, but make sure that the version is set to 0.8.11 because that will match what's in our smart contract. All right, so let's give the deployment another try. There we go. Reference error, Infura API key is not defined. Infura API key. Let's check the spelling in our Env file. Huh, looks correct to me. Infura API key. Let's go back to Truffle Config. Not sure what it's not liking about that. Infura API key. So I wonder why it's saying that's undefined. Oh, process.env. Yeah, I've made that mistake before. Make sure you got process.env so it knows to find this variable in the env file. All right, and let's try it again. Third time's a charm. Okay, excellent. So our migrations were a big success. Everything went smoothly. Now what I want to do is make sure that you're under the #2 lottery migrations sort of block here. I want to grab the contract address, okay, because we'll use this in our front end code. All right, so for now, just go ahead and copy this and just paste it somewhere safe in a notepad or something like that for now, and we'll come back and grab this in a minute. And actually, one more thing we can do is we can grab this contract address and plug it into Etherscan and just get further confirmation that our deployment went through. So if I just plug that in here and then hover over this little, click over this little icon here, and we can see there's a Rinkeby testnet entry for this address. And this is our contract. See, 6 minutes ago, that's about when we deployed it. And we can see the transaction hash, the block number, contract creation, and all the other details about our contract. Okay, so now that our contract is deployed to Rinkeby testnet, let's go back to our code editor and let's continue to work on our front-end app and use the Web3 library to interact with that deployed contract. Okay, so I'm going to close up Lottery for now. I'm going to reopen Lottery dApp. And the first thing I'm going to do is create a new folder. And let's call this blockchain. Okay, and so what we're going to use this folder for is we are actually going to copy and paste our Lottery Solidity contract in here, and we're going to use that to generate something called an ABI, an application binary interface. Now the ABI is something that we'll have to feed into Web3 in order to create a new contract instance or a local copy of our deployed contract in our front-end application in order to use, to basically call methods on that deployed application. And you can sort of think of the ABI as the glue between the front end and the back end, or the passport, if you will, between the JavaScript world and the Solidity Ethereum world. And what it is, it's basically a JSON representation of all of the methods and inputs and outputs in the Solidity smart contract, so that the JavaScript Web3 sort of knows in advance what methods are available on that smart contract for it to invoke. All right, so under blockchain, let's create another new folder, and let's call it build. Okay, and this is where the output of our, or basically our ABI, our generated ABI is going to go into the build folder. So again, let's create another new folder under blockchain, and let's call it contracts. Okay, and let's create one file under blockchain, and we'll call it lottery.js. And so this is going to be the file that actually creates that local copy, that local instance of our Solidity smart contract. All right, so the first thing we need to do is go back into our lottery directory for just a second, and we need to copy and paste the lottery.sol file. So I'm going to copy that and then close this back up, and I'm going to paste that into the contracts folder. There we go. So now we can target this to generate an ABI. And the way we're going to do that is we're going to open up package.json and create a new script. So there's a couple of things we need to do here. So we're going to, first of all, we're going to use something called Solc Js, which is a Solidity compiler, command line compiler that we're going to use to generate the ABS. So we'll need to install that. But before we install it, let's write the command to use it. Makes sense, right? Compile. Okay. We won't actually invoke it until we install it. So I'll say solc for Solidity compiler JS. Now there's a little bit of typing here, so bear with me. Flag ABI, flag include dash path, and then node underscore modules / another flag base dash path. All right, dot space blockchain to reference that new folder that we just created. Contracts, and here we're telling it where the contract is that we want to generate an ABI from. So we'll say lottery.sol. Okay, and another flag, we'll say output dash dir, output directory. And then we'll say blockchain / build. Okay, got all that? Good. Now, next thing, let's go ahead and install the Solc Js. All right, so I need to find a terminal. I've got too many open, so let me close a couple of these real quick. All right, so basically we want to make sure that we're back in our lottery dApp directory. So I'm going to clear that. I'm going to go back up a level. And yep, I'm in the right place. So lottery-dApp. Okay, great. So npm solc js, I believe that's the correct command. Oh, I think it's solc without the js part. Sorry about that. Try that again. Okay, great. So now we can try to go ahead and run our compile script. So I'm going to do npm run compile. And with any luck, this will create an ABI. Missing script compile. Compile. What doesn't it like about my compile script? Missing script compile. Did I forget a comma somewhere? Did I? You know, I may have to just close. I think what I have to do is just close and reopen. And make sure I save this file. I wonder if that was it. Oh no. Okay, I've done something weird here. So let me copy this line just in case I lose it here. Okay, overwrite. Okay, no, we're still good. All right, just a little hiccup here. We need to just reopen the terminal under lottery dApp because I guess it wasn't aware of that compile script since I had written it at the time when the window was open. Npm run compile. Come on. There we go. Cool. So, oh, you know what? It looks like I need to include the Chainlink VRF stuff here. All right, so let's go ahead and try to install the Chainlink contracts. So at Chainlink-contracts. And hopefully it'll be able to read these from the node modules folder. All right, so let's try to run that compile script again. Let's see if this helps at all. Okay, so it looks like we have a mismatch between the Solidity version of the compiler that we just installed and our contract. So let's go ahead and npm uninstall Solc, and let's go to our package JSON, and let's see, go right underneath our React stuff, and let's just install it manually. Solc, and we'll say caret 0.8.11. Okay, save that. Back to the terminal, npm I. This way we're sure that we've got the right version. All right, now let's rerun our compile step again. All right, great. Looks like it was successful this time. We can ignore this error for now. It's just an unused parameter. So let's see what we've got here. Under our build folder, here's what we're looking for. The very last one that says lottery ABI. So go ahead and open that. And basically, here's our ABI. It's a little bit hard to read because it's all in one line, but it's just a JSON object. Copy the whole thing. Let's go ahead and copy that and go back to our lottery.js. And so we're going to create a variable to hold this ABI. And so we'll say lottery ABI equals, and just go ahead and copy that whole thing right there. Then hit enter. All right. So basically the way this is going to work, this is going to be a callable function, or I guess all functions are callable, a callable export rather, that's going to take in a Web3 instance that we've already gotten sort of on the front end and saved into React state, if you remember that step. And so this is going to return a working lottery local contract instance. So let's go ahead and code that up. I'm going to say lottery contract. Okay. And this is going to be a function. It's going to take in a Web3 object. Okay, which is in our React state. And then we're going to return from this a new Web3 instance. So new web3.eth.contract with a capital C. Now this is going to take as a parameter the ABI and the contract address. So here we can reference the variable that we created above, lottery ABI, comma. And then if you remember, we copy and pasted the contract address to a notepad. So go ahead and grab that. Here's where we're going to use that. And in quotes, it's going to be a string. Just go ahead and paste that contract address. Now finally, we just need to export this. So we'll say export default lottery contract, just like that. All right. Cool. So let's go ahead and save that. All right, we can go ahead and close up our build folder and our contracts folder. And in fact, we can close up the entire blockchain folder. All right, so now that we've set that up, let's go back to our main page here, our index.js page. And we can now use this new function to create a local contract instance. So what I'm going to do, let's go ahead and first of all, let's import that file. So I'll go right underneath web3, and I'll say import lottery contract. I think that's what we called it, right? Yeah, lottery contract. From, we'll have to go up one level and then into blockchain, and then lottery. Okay, great. So now we can scroll back down to our lottery handler function, and right underneath where we set address, we can create our new contract instance. So I'll say create local contract copy. Okay. So I'll say LC for lottery contract, and then I'll say lottery contract, the file that we just imported. Remember, we said that's a callable export. So then we need to pass in a Web3 instance. Okay, so we'll just say Web3, since we've set that variable right here. Okay, now what we want to do, once we have this contract instance, we also want to set that into a React state variable so we can use it in various places. So let's do that. Let's set that up first. So back up to our state variables, we'll say const LC contract, and then we'll say set LC contract use state equals use state. Okay, so let's copy the setter function, and we'll come back down here, and then we'll just pass in our lottery contract instance. So that is now set in React state, and we can kind of use it anywhere we want to now. All right, I'll tell you what, let's go ahead and run our application real quick and take a look at what we've got again. So I'll do npm run dev. And so let's think about the first sort of bit of code that we hard-coded previously, and which one that we want to actually unhard-code and fetch the data from the blockchain first. All right, so we've got, let's see, lottery history. Well, we won't really have any data here until we play a couple of games, at least one game. And so to do that, we need to enable these two. Kind of the same with players. So pot, that's an easy one that we can grab. So if you remember, when we did our lottery function, we have a getter function to get balance. So this returns the balance of the contract, which essentially is the pot. So let's use this function in our front end first. Okay. So what we're going to do, we're going to call this function, we're going to use the useEffect hook to call this function once the React components are loaded. So we'll say useEffect, I'll pull that in, and then useEffect. We'll just set up sort of a placeholder for this right now, because what we want to do is we don't want to call the code directly, we want to create another handler. So I'll say const get pot, not that kind of pot, equals, let's see, this will be async, as will all of the functions that we're sort of calling from our contract. All right, so what I want to do here, I'll create a variable for the result that we're going to get. So we'll say pot equals await. So we'll say LC contract, right? Because that's the contract instance that we've got saved in React state. Okay, and now on this, there should be something called methods available. And this will hold, as you can probably guess, all of the methods on the smart contract. So we can say get balance. Okay, and so get balance, it's a read-only function. As you can see by the view modifier here, it's returning a uint, and so it's not modifying the blockchain in any way, which means we can run a call function as opposed to a send, where we'd actually, if we're modifying some information on the blockchain, we'd actually have to send in some ether to run that function to pay for it. But in this case, it's pretty easy, pretty straightforward. We just have to do a call, right, for read only. All right, now let's create another state variable for the pot. So I'll say lottery pot. Oops, I forgot my square bracket. Lottery pot and set lottery pot. So kind of a lot of boilerplate code here just to get things up and running. Use state. All right, and now we can actually say set lottery pot and pass in the result from our smart contract. So this pot value, this is actually coming from the blockchain, from our deployed contract on Ethereum. Okay, so next thing we can do in useEffect, we'll actually invoke this function. But before we do that, we just want to check and make sure that there is a local instance of the contract available. Otherwise, it'll throw an error. So I'll say if LC contract get pot, and we'll invoke that with no arguments. And then as the second parameter of our useEffect, we'll pass in LC contract because we'd want this to rerun if any of these variables change. And we'll say lottery pot. Okay. Now we can use this variable lottery pot and remove our hard-coded value down in the actual card. So down here where we said 10 ether, we'll just remove that and we'll do some curly braces and add our lottery pot there. So, all right, that was a lot of coding. I'm totally not expecting this to work the first time, but let's save it and see what we're getting here. Let's go back up here. Let's refresh the page. Oh, is our thing even running? Yeah, it is. Okay, so we're getting nothing. I was sort of expecting something like that. So let's see what's going on here. We've got lottery pot. There was a lot of wiring up of things, so we may have to start console logging some stuff to figure out what's going on here. All right, so we're setting lottery contract, Web3 set LC contract. That sets our local instance, right here. And then what else are we missing? We're saying if LC contract get pot. You know what, let's just log something to see if this is even getting called. I think that's a good starting point. All right, so I'll just say get pot. Let's save that. And let's open up our console, Control-Shift-I if you're on Windows. The page is refreshing, reloading. All right, so that's not even getting called here. Oh, you know what? I haven't connected my wallet. I think that's the problem. Oh, there we go, 0. Okay, that was weird. I think maybe the page needed to refresh or I needed to connect my wallet. Oh, I see what's happening. So we just clicked this to trigger the on click for it. Okay. You know, let's do a fresh test. I'm just gonna disconnect and we're gonna do this from the very beginning. Oops, not that one. Connected, disconnect. Okay, good. Yeah, we just need to run this test like from a clean slate here. So I'm gonna refresh the page. Refresh, so we should see nothing here, right? Because we're not getting anything back. We're not. Okay, so I need to do connect wallet first. And that's what's going to start to set some of the stuff in motion, right? Set all these React variables. So I'll say connect. Yeah, then we saw get pot being called. And then we got 0 down here. Okay, great. So that's working as expected. All right, so next let's look at wiring up our enter lottery functionality. All right, so actually, you know what we might want to do before we even set up the get or the enter lottery function, we might want to just retrieve the list of players so that when we do set up, sort of wire up this button, that'll be a good test for us to see if it's working because we'll be able to see that address here. So let's do that first. This is going to be pretty similar to the one we just did. I'll get rid of this console log. So yeah, we're basically going to do a couple of things pretty much the same, including setting up a state variable. Okay, so we're going to say, let's see, players and set players. use state, and let's just pass in an empty array to initialize this one. And then we'll set up a function. In fact, we can just copy this one, save us a few keystrokes. And I'm going to say get players. And then down here, I'll say const players. What did I do there? Players, okay. And now let's check our contract to see what function we need to call here. And we've got a get players function right here. Perfect. So let's utilize that. Get players. And again, this function is simply reading and retrieving back a list, so we can use call. And we can say set players and pass in players. I always capitalize the second letter. There we go. All right. Now finally, we can copy this statement on line 16, and let's do, oh, whoops, now this will stay the same. So if LC contract get players. And I guess we could move this all into one if statement, but let's just let it be for now. And I'll say players, so that if the players is ever, augmented with a new value, then this should run again. All right. Am I missing anything? Get players call. Okay. Oops, spelling mistake. There we go. All right, let's try that. Oh yeah, we got to we got to unhard code the value. So players. Let's go down. And it's this one right here, about line 115 or so. All right, so what we're going to want to do is iterate over this players array. All right, so we're getting this from state. We'll say map, and then we'll say player. And then for every player, we'll want to, output one of these things right here. So let's copy and paste that whole link element. Okay. And this is going to become player, because I believe that's just an address. And then we're going to want to use string literal syntax here. And let's do player, $. Oh, this needs outer curly brackets. That's the problem. There we go. And outside of this. Yep. All right, and it's going to want this in curly braces. And what's wrong with my map syntax here? Oh, you know what? This whole thing needs to be in curly braces, so let's just do that and close it right here. All right, and close up our map as well. So that'll be curly brace and then parentheses. There we go. Okay, and then we'll have to do the count as well. So how's that going to work? All right, let's worry about that in a minute. Let's just save this and see if this much works. All right, so I'm going to refresh the page. And I'm going to have to sign in again. So I'm just going to go ahead and disconnect. Yep. All right, refresh the page. All right, connect wallet. Players. Okay, I think that's correct because there are no players right now. I was kind of looking at this one and instead of this one by accident, but yeah, I think that's looking good. So Okay, let's work on the play now or the enter lottery button next, and then we would hope to see a new address pop up here if that part's working correctly. All right, so let's go back to our code editor. And let's wire up a enter lottery function. So I'm going to go right down here on line 30. I'm going to say const, and let's see, what are we going to call this? Let's call it play now, just to match what our button says. So it's going to be async. You know, I really don't like that. Let's say enter lottery. It's a little bit more descriptive. All right. So I'm going to do await lc contract dot methods dot enter, because remember, enter is the name of the function to actually enter into the lottery. Okay. And that doesn't take any arguments, right? Yeah. All right, so this time, instead of call, we want to do a send transaction, since we're actually adding some data to the blockchain and actually sending in some ether. Remember, there's a minimum of 0.01 ether to enter the lottery. So we're just going to make that sort of the required amount here, or the only amount that's possible to send in here. Okay, so from is going to be address, and that references the currently active address in Metamask. Okay. And then we're going to do a value. And we could either enter the value, way is the default, but ether is a little bit more readable, so let's go ahead and do it in ether. We've got a handy little util function that we can use. It's under web3.utils. It's called toWay, because way is a subset of ether, and so you're dealing with a lot of zeros if you specify the value in way. Let's try this. I'm going to say 0.01. I'm not 100% sure that it'll work with fractional amounts like this, but we'll see. And if this doesn't work, then we can just use way. Okay. And what is this? Comma expected. Oh, again, this needs to be an object. Yeah, sorry about that. And close this up here. Okay. Now let's do a gas. I'm going to say 300,000. Let's see if that works. Sometimes you got to play around with these numbers a bit. We'll just do null for gas price. We'll let Metamask estimate that for us. All right, so I think what we want to do is wrap this whole thing in a try-catch. We should always wrap any sort of async function in a try-catch. So I'm just going to copy this whole thing right here, put this in the try clause, and then I'll do catch, error, and we'll just console log the error. Actually, in a minute, we're going to set up some actual error messaging, like a area on the website where we can display error messages. But we'll just do this for now. Enter lottery. Okay, and finally, let's call this enter lottery handler, since technically we're going to call this from the click handler on our play now button. So we'll go down here. Where is it? Right here. Okay, so we'll do onClick equals curly brackets, and we'll paste in our handler name there. Okay, cool. So I think that's everything. All right, let's see if this works. So go ahead and make sure that's saved. Go back to the UI, and again, I'm going to disconnect and reconnect my wallet just to make sure we're running a clean test here. Disconnect, okay, and refresh the page. All right, oh yeah, that's a little bit better. Actually, you know what, I can move this to the bottom now. Maybe that's better. All right. right, so I'll connect my wallet. Next, connect. Okay. So far so good, getting some data from blockchain here. Now let's try our play now. And if everything's working correctly, this should open up the wallet and it should specify the value. Yep, there we go. And so now we just have to sign this transaction by clicking confirm. Transaction has been reverted. Okay, that could be the problem there. Okay, it's not really giving me any useful information. I can guess though that maybe the gas price we set isn't enough. I can open up Metamask and see if it's giving us any more, useful information. Transaction encountered an error, transaction data. Okay, it's not really giving me anything useful here. Let's see. Yeah, so I'm not seeing much useful information here in terms of error messaging, but one thing that I could sort of guess that might be the problem is that maybe we're not sending in enough ether. So we're sending in the exact amount needed to enter the lottery, but there's really nothing left over for gas fees. So one thing we can try to do is just slightly increase the amount of ether we're sending in. And so I think we're going to need to switch to Way instead of specifying that send amount in ether. So all right, let's figure out how to send in the value as Way first of all. So I'm going to do ether to Way and to just search for a little calculator that we can use. All right, so 0.01. And you know what? Let's actually just make it slightly higher than that in case there's any gas fees or anything that we need to cover. That could be the problem too as well. Let's just change this to 0.015. All right. So grab that value and let's go back to our code. And instead of doing all this, let's just send the value in as Way. And let's go ahead and try it again. Yeah, there's a little bit of trial and error here, so I wish I was getting some more helpful error messages. Okay, so yeah, that was successful. Looks like that was the problem. We just weren't sending in quite enough. I think we were sending in the exact amount required to enter the lottery, but not enough to cover gas fees. So that makes sense. Oh, and then we've got the pot listed in Way, so we can actually convert that to ether just to make it more readable. So our player still isn't working. A couple of things to fix still here, but I think we're on our way. All right, so let's go ahead and fix the pot formatting first. We saw that output as Way, but we want to see it as ether. So let's go back up to line 22, and again we can use a web3 util function to reformat that, and we'll say utils from Way. Okay, and so this takes two arguments. The second one is optional. The first one being the value that we want to convert, which is pot, and the second one is the target denomination, but it defaults to ether, so you don't actually have to specify this. I just like to be a little explicit. And then we'll come down to where we're actually outputting that in the UI, and let's just type in ether so that it's clear. All right, let's try that. So I'm going to go ahead and connect wallet. All right. And there we go. We're already seeing the output of 0.045 ether, which is the current pot, since I've now entered into the lottery a couple of times. All right, so that's much more readable. All right, now let's go ahead and fix our players array that wasn't showing up. So let's see if we can figure out what's going on here. So we're calling this in useEffect. First of all, I think we need to back out of this here. We don't need these because this will cause an update to these two variables, which will cause useEffect to run again, and that's going to lead to an infinite loop. So we don't want to do that. The second thing I'm noticing here is that we sort of have a doubly named variable. I mean, we're using players internally here, and we're using players here. I think we should change that. I'm not sure if that's a problem per se, but it's just good practice. And I say that because players is internal to this function, and it might not conflict with this one out here, but I think it's just good measure to keep these named separately. And so we've got get players, and we're fetching the list of players from the smart contract, then we're using that temporary internal variable to set this one right here. Okay. All right, I think that's fine. Now let's go back down to our render area. Where is it? Okay, so we need to update this name now to lottery players. And we need to check to make sure that this actually exists, first of all. So let's check for the existence of that array. Or, I mean, not the existence, but, it's a null check. So we're making sure it's defined, first of all. And then we'll just make sure it's got some length. So length is greater than 0. And then if that's all true, we'll go ahead and render this. Render map players. And then we actually need to return this. And so another thing we might want to do here, this is going to be a list, right? So let's make this an unordered list just so that all of these don't sort of run into each other. Okay, so we'll do li, we'll indent a little bit here, and we'll close that. So let's see if this works so far. All right, so let's just hit on the connect wallet button. Let's open up our console here. And let's disconnect this account. Okay, fine. And connect wallet. All right, so I'm still not seeing anything rendering, so we've got a problem somewhere. Lottery players and lottery players, dot length. There we go. Let's try that again. There we go. All right, we got our list there. Now I don't necessarily want to see these bullets. What can we do about that? And also we need a key property, so let's fix that first. Each li element should have a key equals, and I guess we could just send this, or we could just, this takes an index as a second argument, so we'll just use, let's see, what do we want to do here? Let's say player plus index. All right, so it's going to be player dash index. Let's see if that works. So we'll refresh and we'll hit connect wallet again. Great, and that error message is gone. Okay, you know what, let's get rid of these, let's see, how do you get rid of a bullet point? List style type equals none, I believe is what it is. So let's go back to our styles folder. And let's say, let's leverage our lottery info class again. I think this is on the UL level, if I might be wrong about that, but list style type is none. See if that works. Still there. I wonder if this is on the li type. Let's try that. Yeah, there we go. All right, and we can also do like a negative margin or something. Let's see, what do we have going on here? Margin left is 2em, so if we get rid of that, yeah, that's kind of what I'm looking for. So we'll do margin left is 0. So let me just copy this entire thing. I'll get rid of the li. You know what, I could actually just use Bulma to put this directly on the HTML. Let's do that. So right here, I can say class name equals margin left 0. Let's see if that works. Connect wallet. Yeah, perfect. All right, that is what I'm looking for. And finally, the last thing I think I want to do here is update the count here. So let's unhard code that, and let's say lottery players.length. And let's see if that works. Yep, there we go. So we're seeing R3. Perfect. All right, so we said a little bit earlier that we wanted to find a better way to handle errors. We're just sort of console logging them for now. But I think what we're going to do is let's just set up a dedicated sort of UI area to view errors. So let's see, where do we want to do this? I think let's kind of go right underneath the second button, which is our pick winner button. So under here, about line 102, let's create a new section. Okay. And then inside that, let's create a new div element, and we'll give it a class. Class name equals, we'll say container, and then we can use some special Bulma classes for error messaging. And this is called, I love this name, has text danger. All right, dangerous stuff here. So we will use this for our error message whenever we have one. So let's say error. And now this is going to refer, of course, to a React state variable, which we've got to create. So let's scroll all the way back up to the top. And let's say const error and set error equals use state, and we'll initialize that to an empty string. Okay, so we can copy this set error, and wherever previously we were console logging errors, we can use this instead. So enter lottery handler. Just replace console log with set error. And this is one that's going to be easier for us to test. Right here in our connect wallet handler, we'll set that error message. All right, so let's give this a quick test. Let's go back to the site, and let's, first I got to disconnect. And what we'll do is we'll try to reconnect, but we'll reject the request, and we should see that error message at that point. So there we go. Get rid of this, get rid of that, refresh the page, and we'll see if our error message is showing up. I'm going to do connect wallet, and then I'm going to choose reject or cancel. And there we go, user rejected the request. So I wonder why we're not seeing it. This is supposed to be red, first of all. And while we're at it, let's give it a little bit more upper padding there. Where is it? I may have had a misspelling on the class name or something like that. Yep, never fails. So let's also add some margin top. I'll say MT-6. All right, and let's try that again. Yeah, and we need to reset this, right? So, well, let's just try to connect again. Cancel. Now let's refresh the page. Okay, connect wallet. And cancel. And we're still not getting that red text. Has text danger. Oh my God. Ridiculous. Okay. And there we go. Thank God. I don't have to go through that again. So There we go. That's kind of what I was looking for. Perfect. We've got our error messaging. What we could do is we could actually clear this when we get into the connect wallet handler again. So we could sort of just do set error and set it to an empty string. So that disappears as soon as we try again. All right, perfect. Yeah, I think that's the behavior I want. Great. All right, so let's move on to the pick winner function. All right, so once we pick a winner, we're going to want to display some sort of message confirming who the winner is. So similarly to how we set up the set error functionality, let's do a set success message. All right, so I'll just copy and paste the error one, and let's do success and set success. I guess we call this message, success message. All right, and again, we'll initialize that to an empty string, and we can just sort of come down and we'll just copy and paste the error section and repurpose it for our success. And I believe, if I'm not mistaken, this has text success. There we go, and we'll set this to success message. Okay. I'll tell you what, let's just output this as it is and just make sure that that styling works real quick. There we go. Perfect. All right, so we can go back to brackets now. Okay, so when we did the lottery smart contract, and again, if if you're not familiar with this, you may have to go back to that video and take a look, but we're using something called the Chainlink verifiable random number, which is an additional contract that we're inheriting. And basically Chainlink is an oracle, a service that provides secure data, such as random numbers in this case, and then feeds that back to Ethereum, to our smart contract. And so that costs a little bit of gas. So just as any sort of code execution on the Ethereum blockchain costs Ether, anything on the Chainlink Oracle costs Link, which is their native token. So what we need to do is we actually need to send a little bit of Link to our smart contract before we can invoke the pick winner function, since it's using that random number functionality. So there is a faucet at faucets.chain.link, and all we have to do, first of all, let's set the network to Ethereum Rinkeby. And then we want to grab our wallet address. So go ahead and pop open Metamask. And let's cancel this. Go ahead and make sure you're on account 1 and go ahead and copy your wallet address. And you can paste it in right here. And so as you can see, this is going to send us 10 Link. And it's also going to send us 1/10 of an Ether, which is convenient to have that done as well. And so I'm going to go ahead and send the request. And, just like anything else, it takes a few seconds for the confirmations to come through. All right, we can close this window. And then what we can do is we can display the link in our wallet. So it's not going to be displayed by default. What we need is the Chainlink link. There we go. Chainlink link. Rinkeby token address. Okay, link tokens contracts. I believe it might be under here somewhere. Yeah, Kovan Rinkeby. Yeah, this is what I'm looking for. So we need the address of the link token on the Rinkeby testnet. So now if we go back to Metamask, what we can do is go over to the Assets tab and go ahead and import tokens and paste in that address, and you can see it recognizes it immediately as a link token. And so add custom token, import tokens, and great. So now we can see that we have 10 Link in our account. So now what we want to do is we want to actually send this to our smart contract. All right, so how do we do that? We've got the smart contract address back over in our lottery.js. So go ahead and copy that. We'll go back over to Metamask and we'll click on send. Go ahead and type in that address of the smart contract, and we need to change this over to link. And let's see if we can send all of it. we'll just do 10 link. Might as well. Okay, and go ahead and confirm that transaction. And that is pending. Great, so we are now sending that link over to our smart contract so that it can pay for the Chainlink random number functionality. And if we hadn't done this, then when we went to invoke the pick winner functionality, we would get an error message saying, something like you don't have enough link to cover this transaction. So now we've preemptively made sure that we're not going to run into that problem. All right, excellent. So let's go back over to our index file. And so we're going to need to create a new function. And let's see, how is this going to work? We've got a button for this. So again, we're going to do a handler. So let's say const pick winner handler. Again, this is going to be an async function. Okay, no arguments. And this is going to look very similar to the transaction that we're executing for enter lottery handler. So, I'm tempted just to copy and paste this. Let's just do that. We've had a lot of typing in this video, so anything to save us a few keystrokes is good at this point. Okay, so this time I just need to check the lottery contract and make sure I've got the function name correct. And pick winner. Yeah, so pick winner is going to in turn invoke get random number. And that sort of starts a chain reaction. That's going to invoke the fulfill randomness callback, which is then going to invoke pay winner. So by choosing pick winner, it should result in the winner being chosen and paid. So I'm going to go ahead and copy that. And I'm going to paste that back right here. So we're doing LC contract methods pay winner this time. Okay, so we'll need to send in some value, but not that much. Let's try just 2. See if that works. Okay, so we've got the pay. Well, let's go ahead and copy the handler name and add an on-click to our button. Or is it right down here? So we'll say on-click equals curly brackets and go ahead and paste in that handler. Okay, great. All right, so let's run a test of this and see if this is working so far. Now we've only entered one account number into the lottery, so we're pretty sure that one's going to win. But this is just a sort of preliminary test to see if it's working at all. And then after that, if it works, then we'll have a clean slate with our, we'll have one entry in the history. And then I think what we'll do is we'll set up a success message and we'll look at like the history to get the person who just won the last lottery and display that on the screen. But for now, we're just going to kind of have to look at the balance to see if anything's been deposited and, look at the transactions here. So let's just take a note of the account balance, 2.5088 ETH. Okay, so if this works, basically, and we know account 1's going to win since they're the only entrant, we should hope to see this number incremented, by 0.045, right? So 0.045. So we'll see 0.55 something, 2.55. All right, so let's give this a try. I think we just need to connect the wallet and maybe start fresh here. So let's do that. Yeah, that's exactly what it was. So connect first. Otherwise, we don't have a Web3 instance to work with. We should probably have some sort of custom error message if that's the case in the future. So let's try this again. Pick winner. And this is going to ask me to confirm the transaction. All right, and let's monitor the wallet here to see if we see any activity, because we haven't really hooked up a way for that to work on the site yet. So we say pay winner pending, that's good. Failed, that's bad. So what happened here? All right, guys, so sorry about this, but I just got it to work after I pressed pause on the video. because I was trying to experiment and figure out what's going on without wasting too much time. But basically what I did was I just removed the value field totally from this transaction. And basically that means I'm not specifying the value because I don't know in advance. Obviously we tried to guess how much the gas would be twice and it didn't work. So if you leave this off, then it just allows Metamask to estimate the gas for you and take care of it. And so as long as you have enough in your wallet in general, then it'll cover the cost. So as you can see, I've got a success message here and we've been incremented to 2.55 Ether. So yeah, that's an old error message. So the smart contract should have restarted the game. Yep. And so we're seeing 0 players and nothing in the Ether pot. So that is perfect. All right. So we're going to test again. And this time let's set up a success message once the pick winner goes through and the winner is paid so that we know who actually won. All right. So in order to show the lottery winner, we're actually going to need the lottery history information. So we're back in the smart contract now. And as you can see, lottery history is a mapping of uints, which is the lottery ID, to the address. And that address represents the winner. And we can see if we go down to, let's see, the pay winner, I believe it is. Yeah, the pay winner function. So we're transferring the funds and then we are saying, okay, lottery history of the current lottery ID. Now assign that to players index, which is the winner. We're transferring this to the winner. So players of index is the winner. So we're setting that into history and then we're incrementing the lottery ID. So basically we need to use the lottery history of lottery ID -1 to get the address of the winner for the game. And you might take notice here that we're doing something that I said that you should never do in my security reentrancy attack video, which notice we're doing the transfer and then we're updating state. So I would probably reorder this if I hadn't already deployed it, but in this case, it's actually not a security risk since we're transferring the entire balance of the smart contract. So whoever wins the lottery every time gets the entire balance of the contract, since that's the sum of all of the contributions from the players who've entered the game. So in this case, it's really not a problem. It would be a problem if we were transferring part of the entire balance, because then someone via reentrancy attack could call pay winner over and over again. So anyway, it's not a big deal for this particular example, but just keep in mind in general that you want to do the state updating before you transfer the funds. All right, so with that, let's go ahead and get our lottery history into our front end so we can both display the winner and show the lottery history in the card on the right-hand side of the page. All right, so we're back in our index.js, and the first thing we know we're going to need is a state variable to hold the history information. So let's do something similar to what we've done before, and let's say lottery history, and then set lottery history. Use state. Okay. Now let's see, we're going to want to fetch this and display it sort of at the beginning of the page load cycle. So again, we'll make another entry in our useEffect hook. We'll check for LC contract, and then we'll say get history. All right, and then we need to actually create that function. So we'll say get history equals async function, no arguments, and then history equals await LC contract dot methods. Now we don't have a specific method to get history, but we do know that for state variables, we get an automatic getter under the covers. So we can call this as if it were a function, right? So we can say methods.lotteryHistory, and this is a call since we're just reading information from the blockchain. And oops, I forgot the C, async. Okay. And finally, we can set this in React state. So I'll say set history, and we'll pass in history. All right. So before we try to do anything else with this, let's just go ahead and log it and see what we get back. So I'm going to do console log, and I'm going to say JSON parse, because it's probably going to be an object here. So I'll pass in history. All right, so let's see what we get here. Okay, so we're not going to see anything since we haven't unhard-coded our UI yet. But I'm just going to refresh the page and then hit connect. Oops. Invalid number of parameters for lottery history got 0. Expected 1. Oh, I see. This is a mapping, so it's wanting us to pass in a key and get a value back, so it's not going to give us the entire data structure. That's the problem here. All right, so since we can't get the entire data structure back from the smart contract, I think what we're going to have to do is use the lottery ID, right? So the lottery ID will basically implicitly tell us the length of that data structure, so then we can use it and create a loop in our front-end code to know how many times to look up in the mapping. So we've got lottery ID, great. So let's go back to our index.js file, and so we're going to sort of do the same exercise here for lottery ID. So I'm going to create a new state variable. I'm going to say lottery ID, and I keep on misspelling lottery for some reason. I think I would have done it enough times already. Lottery ID, and then set lottery ID. Okay, use state, and we'll set that to, well, we'll just use nothing here, which will make it undefined until we set it. Okay, so we'll copy line 22, and let's do, so how are we going to do this? We're not going to do get history for now. We're going to do get lottery ID. Okay. And let's copy our get history function, because it's almost going to be identical. So we'll say get lottery ID, and then this will be lottery ID, and then this will be also lottery ID, because again, we have an implicit lottery ID getter. So let's say set lottery ID, lottery ID, and I guess let's just go ahead and print this out to the console. Let's see if this much is working so far. All right, so let's clear that out. Connect wallet. Okay, 2, perfect. That's just what we expected, because we played one game, and so now we're on lottery number 2, right? All right, so now that we've got the lottery ID working, we need to come back and restructure our get history function, because basically the main problem that we're trying to solve here is that we have a mapping in Solidity, and so we need to translate that to something a little more useful in the JavaScript world, which would be probably like an array of objects for this. So since we're going to do an array of objects, let's go back to our lottery history, and we'll make sure we'll initialize it with an empty array. Okay. And so what we're going to do is we're going to come back here, and we're going to create a for loop, and we're going to use the lottery ID to know how many iterations of the loop to do. So I'm going to say for let I equals, and so we'll have that lottery ID here, but I think we need to do parse int first, because I'm pretty sure this is coming back as a string. Okay, semicolon, and then we'll say I is greater than 0. So by the time we reach 0, we'll stop this. So we'll do 2, 1, stop the loop. And then we want to decrement it every time through the loop. You know, with a traditional JavaScript loop, you would start at 0 and count up, but here we're sort of doing the opposite. All right, so we've got our loop set up. Now for each iteration, well, I'll tell you what, let's just console log something just to make sure this much is correct. Console.log, and then we'll say get history. All right, now let's figure out where we're going to call this from. So let's comment this out temporarily. Get history, and So since we have a dependency on lottery ID, I think we should call it from here. And we should probably pass in the lottery ID directly from here, since we can't rely on the state to have been updated necessarily that soon. So we'll say ID here, and then we'll just switch this to ID. There we go. All right, let's see if this much works. Get history. Okay, connect wallet. Wait, what were we logging? Get history. Okay, cool. Yeah, it looks like that loop is working. So let's go ahead and continue. All right, so let's attempt to now put some of this data inside. So what do we want to do here? We want to reference that mapping each time for the current ID that we have in context. So let's uncomment this. And so we got to change this a little bit. So let's do this one line at a time. So first we're going to call lottery history, right? But this time we got to pass in the ID. Okay, and that's going to correspond to the uint right here. Okay, this is going to be a required parameter for this getter. So then this is going to pass back an address, right? Winner address. So now what we have to do is construct an object that we can then push into our history array. So let's do it like this. Let's say const history object. I'm sure I could think of a better name for that, but you know, for now, let's just do this. History object dot ID equals ID. And then history object dot address equals winner address. All right. So then we just need to set lottery history, and we need to push this into our state array. All right. So to update this array, let's see, what's it called? Lottery history, right? So we would normally do push, but here we need to do it a little bit differently. Lottery history. Okay, and then the reason we're doing it this way is because we never want to mutate state directly. Okay, to prevent errors and side effects and things like that. So we're gonna basically copy the existing array and then add a new element to it, which is going to be our history object. All right, so hopefully that'll see ID history object. Okay, history object dot. Now what is this? Oops, I think this. There we go. ID. There we go. I just forgot a return there. Okay, that looks good. All right, so let's just check and console log the object just to make sure everything is working up to this point. So I'm going to say json.stringify, since it's an array of objects, we won't be able to see that by default. And I'm going to say lottery history. All right, so let's go ahead and save that and see if we're seeing anything in the console. Oops. JSON stringify. Stringify. There we go. All right, let's do connect wallet. Empty object. Okay. Why would we be getting an empty object here? Console log 4. Oh, okay. I think this is running before we're getting all of our async await methods to return. That's the problem. That's why it's empty. So how do we fix that? All right, let's just try moving our console log back into the get lottery ID function below our get history. And let's just put an await keyword here so that we're ensured that this runs once this is completed. Let's see if we get any better results from this. Oops. Okay. Oh yeah, there we go. Perfect, that's exactly what we wanted. Okay, so now we've got, oh, why is this ID 2? And address 0. Oh, interesting. Well, I guess that's correct for ID 2 since we haven't played the game and we haven't entered anyone into the game for ID 2, but I wonder why we're not getting ID 1 here. Maybe we're, let's see, let's look at our loop again. Let I equal parse int ID. Okay. I is greater than 0, that's correct. We're de-incrementing it every time, so we start with 2. Right? Let I equals parse int. Okay, so that's an integer, so we're able to decrement it. Maybe there's something wrong with this line here. Console log git history. Oh, I see. Well, this needs to be I, not ID, right? Because we've assigned ID to I, and that's what we're actually decrementing, so that really represents the lottery ID at this point in the code. So let's save that. Let's try it again. No, I don't want that. Connect wallet. Okay, there we go. That's better, but address. Did we do the same thing for address? Probably. Yeah, we need to reference I instead of ID here. Let's try that again. Nope, still getting a 0 address. There we go. That's what we're looking for, right? Because this was the winner the first time. That should correspond with my wallet address 1. Yeah, C143. Okay, great. So that's finally working. Okay, so we've got a reliable history right now. So let's set a success message using that history. And so what do we want to do here? We want to basically, right now, we're on ID 2, right? And as soon as the winner is paid, it increments the ID of the lottery. So we actually want to look at the last one and get the address from that. So let's go to our pick winner function, our handler here. All right, so once this is done, so we'll go under here on line 73, we want to set a success message, but let's first create a variable. We'll say const, and we'll say winner address equals. Now at this point, we should be able to reference our state object, our state object directly. So let's say lottery history. Now remember, this is an array. So what position are we looking for? Lottery history at lottery ID -1, right? Since that's already been incremented. Lottery ID -1. Okay, so history, lottery history at lottery ID -1. And then dot address. That should give us the winner address, right? So let's set our, we want to set our success message. Set success message. And we'll say the winner is, and we'll reference that winner address above. Okay, great. So we could go ahead and test this right now, but let's just go a little bit further and try to get some lottery history going in our right side panel here. Like this is the last thing that we've got hard coded. So let's try to fix that, and then we'll test everything together. Okay, so what do we need here? Let's go down to our lottery history code and take a look. Lottery number 1 winner. All right, so I guess we're going to have a different entry for each history entry. So basically what we'll need to do is create a loop and loop over the lottery history array and then output one of these elements for each entry. So let's try to do that. So we're going to say, well, so first we need some curly braces here so we can write JavaScript inside our JSX. All right, so this is the array, right? Lottery history. So we'll want to do a check similar to what we did down here. So lottery history, let's put this in a parentheses, lottery history and lottery history dot length is greater than 0. And now we can start our loop. Lottery history. And so inside here, let's just say item okay. Does that look correct? Yep. All right, so inside of this one, for every item, we're going to return one of these entire objects here. So let's copy that and paste it into here. Whoa. All right, and I'll just fix the formatting a bit. This needs to be tabbed over because we're going to do a return. So we're going to return one of these for each one. So let's just see if this much is working. See, it's good to check at small increments here. What doesn't it like here? Lottery history. Oh, I forgot the map. All right, map. There we go. Let's see if it likes that any better. Okay, let's just clear that out and let's do connect wallet. Cool, so at least we're getting 2 entries. So now we just have to add the values in there. And you know what, let's add some padding. I saw that looked a little bit tight there. Margin top 3 maybe, let's try that. Yeah, that looks better. Okay. Okay, so the first thing we want to do is create a variable here, right? So let's see, can we do item dot, what did we call it? ID or lottery ID? I forget now. I think lottery ID, right? Just ID. So ID. Let's see if that much is working. Perfect. Now we got 2 and 1. Okay, so the only thing left to do is the address. So let's start here, and we'll do item dot address. I believe that's right. Let's just check that real quick. Cool. Okay. And then we'll sort of do the same thing right here in our URL. So we'll have to do some refactoring here, and we'll make this a string template literal. Let's see, how is this going to work? So we delete the actual hard-coded ID. We paste in our item.address, closing quote, and closing curly bracket. Oh, whoops, we lost something here, didn't we? Let's put that back in. All right, now let's check that. So let's see if this takes us to the correct address here. Oh no, something went wrong there. Oh, I think I need a $sign here. Right. I always get the template, a string literal, and the React syntax mixed up. So let's try that again. Yep, that's more like it. Cool. All right, so the other thing is we don't really want to show the current lottery, right? So how can we fix that? How can we fix that? Let's say if item.id is not equal to, let's see, how's that going to work? Is not equal to lottery ID, right? So we'll say if lottery ID is not equal to item.id. So in other words, as long as we're not talking about the current lottery, let's go ahead and display it. Let's see if this works. Okay, something wrong with that. Now, lottery ID is not equal to item.id. You know what? Maybe we don't need to check for type because one of them is probably a string and the other one's probably an integer. Yeah, exactly. Cool. So now we're just showing the previous winner. And we're showing it multiple times here, which I guess is another thing to figure out. All right, cool. So our history, our lottery history UI is in a good place. Seems to be outputting the history correctly. And we've also got it wired up to output a winner. So let's do another test and let's enter a few of our wallet addresses into the lottery. Let's do pick a winner and see if we're getting that success message now. So this is basically the final test just to make sure everything is working correctly. So I'm gonna disconnect my wallet and start fresh here. Disconnect. Yep. Go ahead and refresh the page. All right. So let's go ahead and connect our wallet. And so we'll assign this transaction to connect us to the site. All right, and so that triggers our useEffects hook, and we're seeing the ether, we're seeing 0 players, which is correct, and we're seeing the lottery history. So far, so good. So let's go ahead and play. So we're still set to address number 1, so we'll enter him in. And we've got our minimum amount there. Let's confirm that. And we'll monitor in Metamask to make sure that transaction goes through. It's still pending. All right, that succeeded. So let's go ahead and choose another account. Oh, it looks like we're low on ether. So what I'm going to have to do is send my accounts 2 and 3 some ether. All right, let's do that first. So I'm going to copy account number 2, go back to account number 1, and I'm going to do send. Let's send him like half a ether. Confirm. And let's do the same for account number 3. Oh, account number, okay, so yeah, it's called attacker, but that's just because I was doing another video. No malicious code in this one. So we'll copy that, go back to account 1, and we'll do send, and we'll send him 0.5 ether as well. He's an ethical hacker in this video. He's helping us test the lottery contract. All right, so that's pending. While that's pending, okay, we can see that account 2 is now loaded with some ether. So while we're still waiting for the attacker count, let's go ahead and, so we'll connect account 2 to our lottery application. All right, now we can go to play now. We must provide an Ethereum address. Okay, good, we're seeing 1 player entered. All right, so we're now connected. All right, let's go ahead and confirm. And hopefully we should see the player's card incremented in just a few seconds. All right, great, that went through successfully. And now let's switch to account 3, which is the quote-unquote hacker account. And great, now he's got 0.5 Ether, so we'll connect him. All right, let's do play now. Well, that's weird. We're getting this error like the first time. Must provide an Ethereum address. Okay, I think we have to hit connect. There we go. Let's try it again. Yeah, that's right, because we're not setting the account 0 as address until we actually hit connect wallet. There we go. So let's try play now again. All right, confirm. And that transaction is pending. Looks like it's successful. And so we have to kind of hit connect wallet to get this players to update. So that's maybe another thing that we could think about fixing. All right, so let's try pick a winner. Now remember, we're still on the third account, so this should fail. Let's try that failure. Pick winner. Now hopefully our smart contract's going to recognize that this is not the owner. So we'll confirm. That's pending. Hopefully it'll get rejected. If not, then we've got a major problem. All right, so the good news is that our success message is working and we're outputting the winner. The bad news is that we were successfully able to pick winner with an account other than the owner. So I don't think it's a smart contract problem. I think it's a problem with how we're storing the address. And as you could see, sometimes we only saw updates when we connected the wallet. So I think what we need to do is sort of update all of these variables, history, players, when we invoke play now and pick winner, as well as the current address. So let's see how we can actually do that. So looking at the behavior here, the fact that account number 1 was the winner again, and the fact that despite switching to account 3, we were able to invoke pick winner, sort of leads us to suspect that probably, despite changing our accounts in Metamask, it's not syncing properly with the site, and the site still sees account 1 as the current account. So if we look at the Metamask docs, it looks like there is an account changed event here that we can use. So we can do Ethereum on accounts changed to detect whenever a new account is set as primary in Metamask. So let's go ahead and try to use this. So we can, let's see, we'll go somewhere closer to the top, I guess. Underneath use effect, we can say window.ethereum.on, and let's see, what was the event? Accounts changed, right? And then we pass in a handler as the second function. All right, so here what we'll want to do is sort of replicate the code that we had in the connect wallet handler to set that new account. Okay, so yeah, we want this code right here. Accounts. So I'm not sure about this syntax, accounts at 0. I'm not sure if this will still point to the main account or the one that's actually in focus, so to speak. I wonder if the docs say anything about that. All right, let's try this and see. I'll tell you what, let's just output account 0 at this point and see what it is. Account 0, there we go. Let's go ahead and save that. Let's go back to our site. Oops. Oh, async function. All right, so this needs to be async right here. There we go. Save that. Let's try again. Okay, so let's try to change our accounts in Metamask, and we'll switch it to account 2 this time. Account 2. Okay, perfect. That is outputting the correct one, OBA. Okay, that's good. So let's get rid of our console log. And so we're now setting account 1. In this case, that's the account that we changed to. So we just verified that. So now we'll have the correct account. So another thing I think we should do, because we were sort of having to click on Connect Wallet when we shouldn't really have to, after some things like Enter Lottery and Pick Winner. So what if we take all of these and extract these to a common function? Let's go right underneath here. And let's just call it update state. And so we'll gather all of these sort of together. And so now we'll say update state inside of here. And now we can also kind of have some more leverage to call it from other places as well. So let's do it right after our enter lottery, right after the success anyway. And let's do it in our pick winner. Let's see, where do we want to do this? I guess we can do it right at the end here. All right, so let's, with those changes, let's try our test again. Okay, so I'm gonna go ahead and disconnect. We're gonna change back to account number 1, and we're just gonna disconnect. Well, I guess we've got to disconnect all of these, huh? Okay, disconnect, disconnect, disconnect. Good. Let's clear that, and let's refresh. Uh-oh, window is not defined. Why is window not defined? All right, well, I guess we're going to need that same check that we had in Connect Wallet Handler. Let's just copy this real quick. Yeah, make sure the object, window object exists. You know, we could probably just put this all into use effect, couldn't we? Because we just kind of want this to run one time to set that handler. Let's try that. And that way we shouldn't need this check, right? Let's get rid of that. Let's see if this works better. Save that. All right, let's reload. All right, so hopefully that's going to work the way we expect. So let's do our experiment here from scratch. Connect wallet. All right, so we'll connect wallet number 1. Oh no. Okay, web3.eth. Okay, so Web3 is not available here, so we're kind of in a chicken egg scenario. So we can't run this in use effect because we've got to make sure that we have a Web3 instance. All right, so I think this code is actually going to go in our in our wallet handler. We should have foreseen this. So where can we put this? Let's just put this sort of at the end here. All right, I think this should work here. Let's try again. Each child in a list should have a unique key property. Where is this coming from? Index 87. Oh, this is probably referring to the lottery history. Yeah. Yeah, so we need a key property here. And let's see, let's say item.id. I think that'll be good enough for now. Okay, let's start our test over. Let's disconnect here. All right, starting fresh. Connect wallet. Great, so far no errors. And we'll go ahead and connect account number 1. All right, now we'll do play now. Okay, and we'll sign this transaction. Okay. Players is still at 0. We want that to update as soon as we enter into the game. So let's go back to our code. Enter lottery handler. Okay. Update state. So I guess this just hasn't incremented at the time that we're calling it. Let's just try to continue our test here. Oh, there it goes. Oh, I guess that was maybe just waiting for the confirmations to go through. Okay. So here's the real test. We're going to see if our on-chain handler is working. So let's go to account 2 and we'll do connect. Okay, play now. Confirm. All right, and let's open Metamask to monitor that. Pending. Okay, great. So that's been incremented. I was just impatient the first time. All right, let's switch to our third account. Okay, so I'm going to go to my friendly attacker account and we'll say connect. Good. Let's do play now. And confirm that transaction. Monitor, rinse and repeat. So yeah, it takes just a while for things to go through and get confirmed into the blockchain. So we've got to be a little bit more patient than normal. With a centralized model, you know, we'd get an answer right away. But hey, I think it's worth it for decentralization. There we go, 3 players. Okay, so now note that we're still on account 3, and so let's try to pick winner, and hopefully we'll see this rejected this time if our on event handler is working correctly. Okay, confirm. Well, it looks like that's not working because we're still getting the same result here. Darn it. Well, at least we fixed some of the things we're seeing over here. Lottery history, we got a new entry. Our players are, being incremented. Our pot is everything's being sort of incremented and updated in real time. So we've still got the issue of, our wallet provider or our, Web3 instance is not detecting our account changes. All right, so there's one improvement or correction that we need to make in the pick winner handler, and that is that we can't really rely on this lottery history React state variable because it will not have been updated by the time we reference it here. So let's get rid of that, and what we want to do is actually call history from the smart contract. So we're going to want to do something similar to this that we have on line 42. So I'm actually just going to grab this right here, and we're going to go back down to line 77 and paste that in. So I can say lottery ID call, okay, and that should give us the winner address. And so one other thing we can do is we can reset the error messaging, like anytime we call pick winner handler or enter lottery handler. Okay. And then the one other thing that we were seeing is that for some reason we were allowed to invoke pick winner even when we weren't on the owner account. So let's just console log our address at this point. Okay, and let's just say address from pick winner. And let's just make sure that it's actually reflecting the correct address. All right, so with those changes, let's do one more pass through our testing routine and see if we see some improvements here. All right, so I've created a couple of new accounts for this test, and the reason I did that was just because we'd seen account 1 win like a lot of times, so I just want to make sure that we exclude that from the test and make sure there's nothing hard-coded or anything weird going on with the 0 position account. So with that said, I'm going to go ahead and click on connect. And this time we've got accounts 4 through 6 available. So I'm going to start with account 4 and we'll add 4, 5, and 6. Okay, so we're connecting and let's do play now. And we'll go ahead and accept that and enter ourselves into the lottery here. All right. Oh, we don't need to connect. We need to actually switch accounts. So we will switch to, let's see, we'll do it manually here. We'll go to account number 5. There we go. And we want to connect. Great. Let's enter him in. All right, we'll accept. And then let's just make sure we got a couple of entries here. Great, still waiting for that second one. In the meantime, we'll go ahead and enter account number 6. Account number 6, connect. All right, and let's do play now. Okay, and we'll accept that entry. All right, so we've got everyone entered in. We're still waiting for some confirmations on that last one there. But what we can do is start to record the balances, the actual balances in the wallet, just so we can really tell who the actual winner is. So I'm going to grab the balance for account 6, and we'll go ahead and update these to reflect our new accounts. So we'll have 4, 5, and 6. All right, so let's check the balance on account 5. All right, and then we'll do the same for 4. They're all pretty similar, so we'll make sure we note these here. Yeah, they're almost the same, so that's good. It should be easy to tell who's the winner. And so with account 4 still selected, I will go ahead and invoke pick winner. Okay, we'll confirm that. And let's see what happens here. transaction is still pending. All right, so our winner is 302C, which is, looks like it's the fourth account, and we can see that that balance has been incremented. All right, so the problem that I'm seeing here is that so far every test that we've done, the first account that we've entered has been the winner. So that definitely raises a red flag. And if I think back to our lottery contract, let's see what exactly happens when the winner is being determined, right? So we do pick winner, we get a random number, and so that sort of kicks off the call to the Chainlink Oracle. So that's some off-chain processing. And I think what's happening is we're actually not getting the result before pay winner is invoked. So we're doing get random number. We're calling that function, right? That comes back, where is it? Get random number. Get random number, and then there's a call to request randomness. That's in the Chainlink contract. Eventually, fulfill randomness. That's a callback that gets called with the result of the random number. And so then we're setting random result, which is a state variable from our contract up here, right? So I have a feeling that what's happening is by the time we get into pay winner, we don't actually have the result back from the randomness. And so this is always equaling 0. I don't know if this is undefined or if it's 0 or what. I think 0 is what it initializes to. 0 divided by player's length. So we're getting a 0 index every time. That's why the first player entered into the lottery is always winning. So unfortunately, I think we're going to have to make a change to our smart contract, and we're just going to have to decouple the randomness from the paying of the winner, if you know what I mean. And if you think about it, that's okay, because in a lottery, you know, we'd have players entering the system, and during our testing, we're entering people into the lottery, and then we're trying to get the results immediately after that. So, you know, in a real lottery, you've got people entering in, and then some time elapses, and then sort of the winner is chosen. So it's okay if there's some time between those two events. So I think what we're going to have to do is decouple this pay winner. And that's going to be pretty easy to do. I think all we have to do is remove pay winner from here, and then we'll just have to invoke that as a separate function call. And then one more thing we can do, which we probably should have done at the onset, is to just have a require statement and just check and make sure that that random result is greater than 0. So I'll say require random result greater than 0, and then let's say must have a source of randomness before choosing winner. Okay, semicolon. Okay, so let's go ahead and we need to copy this entire thing because remember we're still in our front end app. Yeah, so let's go back up to our contracts folder, and we can just replace all the code in here with our updated code. All right, so let's open our terminal again from our lottery folder and rerun our migration. So I'll say Truffle Migrate Network Rinkeby and hit enter. All right, and so for some reason it's not really detecting a change because the migration should be run whenever code is changed in one or more contracts, but for some reason, so we saved our file, yeah. So what we can do is rerun this with the reset flag, which will just push all the contracts regardless. So let's do that, and I'm going to add a reset flag, and let's try that again. All right, this will take a few minutes, so I'll go ahead and pause the video here. All right, and that deployment succeeded that time, so again, we'll go back up here and let's go ahead and grab the contract address. Go ahead and copy that. Now we're going to need to go back into our front end project, and we need to go to our lottery.js and just replace the contract address right here with the new one. It is actually good practice because it kind of shows what you need to do if you find a mistake in a smart contract and you need to redeploy it to a new one. Okay, so let's go back to our front end terminal. clear this out. And so what we want to do is rerun our compile command to generate a new ABI. So npm run compile. All right, and once that's done, I should have cleared the build folder first, but we'll just wait for this to complete. And then we'll grab that new ABI and paste it into our, right up here actually, in our lottery.js file. So we'll just pause the video. All right, great. So that compile step is complete. So we can go back up into our build folder, and again, we can open up our lottery.sol ABI and just go ahead and copy everything. Bring it back over to our lottery.js file. And everything starting from about here will replace. Okay, perfect. Great, so now our front end will be pointing to we'll generate a new contract instance with those updates. Okay, so let's think about what we need to do for our front end code. All right, so let's look back at our contract, smart contract. So now we're gonna break this into two parts, right? We have pick a winner, which is gonna really now end with the generating of that new number. So we'll do pick winner, and then with pay winner, we'll have to have that as a separate function. So let's go ahead and build that out. So let's go right underneath our pick winner handler, and let's create a pay winner handler. Async. It's going to be pretty much the same as our other handler functions here. Async. All right, so again, we'll clear all of our messaging, error, and success. Then we'll do a try catch clause here, as we're doing with most of our async contract calls. Catch error. Okay, and we can sort of borrow some code from up here. We'll say set error, error message. And then down here, we'll say await LC contract dot methods dot pay winner. Okay. Now let's see, this one's going to be a send as well, so we could just copy everything up until here, paste it right down here. There we go. All right, what else do we need here? So actually what we need to do is sort of move this code down into pay winner, right? Because previously the pay step was happening here. So we can just copy everything from there. And we'll paste it right down below here. All right. So one thing we want to do is actually check to make sure the random result. So this pick winner handler, how is this going to work now? So I don't think we need any variable to check our result here. I think we can just do that in the pay winner handler. So the first thing we need to do is we need another await. This can just be a call. So I'm just going to copy about this much. And methods, I'm going to say random result. Actually, we have this check in pay winner, don't we? All right, so yeah, that's right. Our smart contract should be, that's right. Our smart contract should be taking care of this check for us. So, okay, so I think we just need a pay winner handler button. So let's go down in our code to where we have our first two buttons. And we're just going to copy a section from the last one, because it's going to look very much the same. It's also going to be admin only, so we can leave that text. We'll say pay winner. And we'll choose the pay winner handler. So really we just have to change one word here, pay winner handler. let's just change the color a bit. So we'll say success is success button, and we'll change this to pay winner. Okay. Oh, and one last thing we need to do is change the function in our click handler. So let's go back up to, where is it? Pick winner, right? And we forgot to change this to pick winner. There we go. All right, go ahead and save the file. I think this looks good, so let's go ahead and do one more test. All right, so this is our final test, and hopefully with all the improvements we've made, everything will be working flawlessly this time. All right, so don't forget, since we've deployed a new contract, we need to send it some new link. Okay, so again, you can come back to the faucets.chain.link and request some test link. I think I've still got some, so I'm just going to send some to my contract. And I've gone ahead and pasted the contract address right here to Notepad, so I can go ahead and just click on send. I want to change this to link, and let's go ahead and send 20 link. Okay, and we'll go ahead and confirm that. 20 should be more than enough, by the way. I think 10 would be fine as well. So, okay, once that is, we can go ahead and start testing in the meantime while that's sending. We're waiting for that transaction. So, okay, let's start fresh here. We're going to connect a wallet. And we'll use account number 1. We'll go ahead and connect. All right, and we'll go ahead and enter him into the lottery. Confirm. All right. Let's enter in account number 2. So we'll switch over to 2. We'll click connect. And we'll click play now. And we'll go ahead and confirm for account 2. All right, let's switch over to the friendly attacker account, ethical hacker, and let's click play now. And go ahead and enter that one in. And I'll tell you what, let's go ahead and just enter in the remaining accounts so we have a really good test here. So I'm going to switch down to 4, connect, play now. Confirm, rinse and repeat. We will select account 5. Okay, connect, play now, and confirm. One more time with feeling. So we'll go to account 6. There we go, connect, play now. And I said, and where are you? There we go. Confirm. Okay, cool. So we should have like 5, and we should soon have 6 players in the game. And we'll just wait for that final player to appear. And there we go. Okay, so we got 6 now. So we're still on account 6. Let's go ahead and attempt to pick winner. Now, if you remember before, this should be a owner-only function, but we were able to do it earlier with other functions. So let's see if our refactoring has made a difference. Okay, that pick winner is still pending. So we'll see what happens here. And we got a failure. Okay, that's actually a good sign. So with any luck, that problem has been fixed with our refactor. So let's go ahead and switch back to account 1 and try the same thing to test that theory. All right, so we're back on 1, and again, we'll do pick winner. Okay, and it's going to ask us to confirm. And our error message has been cleared. Excellent. So we've got a success there. Okay, so let's try to immediately pay winner And my theory is that this should not work immediately because, as we saw, it takes a couple of minutes, and we have that check for the random number. So let's see what happens here. Yep, and there's our error message. Okay, so far this is looking great. So I'm just going to pause for like 5 minutes here because I remember in the past it took up to 5 minutes for that random number to actually get generated. We could add another button here to check it and periodically sort of press that button and see if we're getting a random number, but I really don't want that in my lottery interface, so I'm just going to wait. I'm going to pause the video here and we'll come back in 5 minutes and try this again. All right, guys, so it has been more than a couple of minutes, so let's go ahead and try again. So we'll do pay winner. Still on account 1, great. Go ahead and confirm. All right, and we've got a winner. So that means our random number is in place and it's been successfully used to randomly pick a winner. And we've got 0BA, if I remember correctly, I think that's account 2. Yep, 0BA, there we go. All right, so it looks like up to this point everything is working correctly. And everything's cleared out here. We've got a winner for lottery number 1, so everything is working great at this point. So it took us a little bit of work and some experimentation and some refactoring and stuff to get this all working, but hopefully you guys got something out of it and sort of saw what it looks like to debug these things and even have to make changes to the Solidity contract itself and redeploy. So. All right, guys, so that is all I've got for today. Hope you enjoyed it, and a couple of people specifically requested this video, so I want to thank them for that great idea. I think this was a pretty good exercise to go through. So yeah, if you guys are enjoying the content on this channel, I definitely encourage you to subscribe. And other than that, I hope to see you in the next video, and until then, take care. Bye now.